Let's consider this figure here. This is a composite three-dimensional figure that is made up of a cone and a cylinder put together. So this in real life could be a building, for example. They don't quite fit together here. But let's say they did. And let's say we wanted to know the volume of this composite figure. Well, volume is pretty simple. It is simply going to be the volume of the cone plus the volume of the cylinder. So let's see how we would do that. So I have some measurements here for the cone and for the cylinder, and they both have a base radius of 3. So the volume of the cone, and notice how I've laid out my work here. I have the cone and I have the cylinder, and I am literally going to write out both parts of this. I highly encourage you to do that so you don't lose track of where you are. So the volume of the cone is going to be 3, which is the radius, squared times pi, times the height divided by 3. So on top, this is going to be 36 pi over 3, so that's going to be 12 pi. Now for the cylinder, the radius again is 3. The height you see is 6, so this is going to be pi times 3 squared times the height, which is 6. So that winds up being 54 pi. And we're just going to add these two amounts together. So 12 pi plus 54 pi is going to be 66 pi. And that would be in cubic units. Pretty easy, right? So let's now go to, as I erase all of this, now we're going to talk about the surface area of this shape. Let's bring our shape back. Oops. The surface area is not going to be quite as simple as finding the surface area of each part of the figure and adding them together. Why is that? Well, because as we put these two figures together, like so, two faces of the figures go away. We no longer see the bottom or the base of the cone, and we no longer see one of the bases of the cylinder. We do see that base there. So the way we're going to do this is that for the cone, we are going to take the surface area and subtract the base, which is the area of the base, which is pi r squared. We could also just simply find the lateral area of the cone. They would amount to the same thing, but just for illustrative purposes, I'm going to show it to you this way. Then we're going to add the cone's adapted surface area with the cylinder. So the cylinder is going to be the lateral area of the cylinder, which is 2 pi r times height, plus 2 pi r squared. That would give us the entire surface area, but then we're going to subtract one of those circles. So of course, this is going to, well, we'll clean that up later. Let's go ahead and do this. So the surface area of the cone is going to be 1/2 circumference times slant height plus pi r squared. And then we will subtract the pi r squared. Well, those are clearly going to cancel out. So this is going to be 1/2 times 2 pi times the radius of 3, which is just going to be, it's just going to be 3 pi. Because the 1/2 times 2 is just going to go away. Over here, whoops, excuse me, I forgot my slant height. So that's going to be times 5, 15 pi. There we go. 15 pi it is. Now over here, we're going to have 2 pi times the radius times the height. Of course, these guys just come together to be pi r squared because we had 2 pi r squareds and then we subtracted 1 pi r squared, so it just gives us pi r squared. So we're going to add pi times 3 squared, like that. Well, cleaning all of this up, this gets us to 36 pi. This gets us to 9 pi. Together that makes 45 pi for the cylinder. We're going to add the 15 pi, and that gets us a total of 60 pi square units for the surface area of that composite figure. So if I had any final advice to give, volume is easy. You're just adding those two volumes together. Surface area, you need to start with the surface areas of each figure, but also subtract the sides that are obscured when you put them together. And that will very likely, if not always, affect the areas of both individual shapes. Thanks a lot.